Hello students, in this video we'll discuss a paradox that involves partial derivatives. Let's consider polar coordinates. In polar coordinates, x is r cosine theta and y is r sine theta. The inverse transformation in polar coordinates says that r is the square root of x squared plus y squared, the distance that xy is away from the origin, and theta is the angle that the vector xy makes with respect to the positive x-axis, which is the inverse tangent of y over x up to quadrant. You have to make sure that you're in the right quadrant. You can't just compute the inverse tangent then without reference to where x and y are located. Now, what I'd like to compute partial r, partial x. That's our goal, compute partial r, partial x. I'm going to do this in three separate ways. I'm going to take this first equation over here. So method number one says that, well, according to this first equation, x is r cosine theta, which says that r is equal to x over cosine theta. Therefore, according to this equation, dr dx is equal to 1 over cosine theta. That's our first method. What's our second method? Our second method takes the second equation, y is equal to r sine theta. So according to method 2, y is equal to r sine theta. And that tells me that r is equal to y over sine theta, which tells me that dr dx, well, there's no x's over here, so dr dx, according to this equation, will be equal to 0. Okay, great. Uh-oh, that seems a little bit weird. And the final method we'll use 3. I will use this relationship over here, that r is equal to x squared plus y squared. So according to this last relationship, r is equal to the square root of x squared plus y squared. And the derivative, according to this rule, dr dx, will be 1 over 2 square root x squared plus y squared times the derivative of the inside of the square root with respect to x. And so that's going to be a 2x. So we have x over the square root of x squared plus y squared. Now x is r cosine theta, so this is r cosine theta. The bottom is just going to be r. Those r's cancel. And according to this method, method 3, the derivative of r with respect to x is cosine theta. So the question for us becomes, what is dr dx? Is dr dx choice 1, 1 over cosine? Is dr dx 0, according to choice 2? Or is dr dx cosine, according to choice 3? We have 3 very different answers. Which answer is the correct answer? Well, the short answer is that all of these answers are correct, because all of these answers have a particular context. Let's think carefully what we're doing in each case. In this first case, I'm doing partial r, partial x, and what am I holding as constant? Over here, I'm treating theta as a constant. So in this formula over here, I'm doing dr dx, and I'm treating theta as a constant. In this second equation over here, what are we doing? We have r as y over sine theta. We're treating both y and theta as constant because I said that this does not depend on x. It's a constant with respect to x. So in this partial derivative, I'm holding y and theta constant. So y and theta are constant. And in the final equation over here, what are we doing? In the last equation, we're saying, okay, well now we're doing dr dx. The only thing I'm holding constant over here is I'm doing the derivative of r with respect to x, holding y constant. So over here, we're holding y constant. So we have 3 separate constrained partial derivatives. Each is correct in their own context, and so that's why when we compute partial derivatives, it's important to let the computer know what variables are fixed and what variables are constant. So partial derivatives completely depend on the context of the problem. So in some contexts, this first one might be right. In other contexts, the second might be right. In other contexts, the third might be right. The most used context is this third context, the derivative of r with respect to x, where y is constant, and the other variables are allowed to what? The other variables are allowed to change. So theta will be allowed to change over here. So in this derivative over here, theta is allowed to change. In this equation over here, what will allow to change? Y is allowed to change. So y can change in number 1, and theta can change in number 3. Typically, we care about this relationship over here because most oftentimes x and y are together considered independent variables. So on this level, this is the most commonly used one. So traditionally, you'll see in most textbooks them just write dr dx is cosine theta. But when they say this, they really mean dr dx, treating y as a constant, letting all the other variables vary. Thank you very much.